Okay, ladies and gentlemen, good morning to you guys. I'm just going to go through the drill that I do every morning, which is to remind people where are your lectures located if you want to see them again. They're in Canvas, in the lecture module portion, and they're by date. So what's today? 28th. Good job, ladies and gentlemen. So remember, what we've been working with is derivatives, right? So we're going to continue to work with derivatives. We're going to be working with a lot of derivatives. So that work is going to continue, you know, derivatives, derivatives, derivatives. I just got to find 261. Ooh, okay. There we go. All right. Power rule, product rule, quotient rule. I don't want to do this derivative of trigonometric functions. So we're going to give you some more derivatives, ladies and gentlemen, okay? And so let me show you guys, you know, how to differentiate. You know, we're going to do this over the weekend so you guys get some good practice with derivatives. Now, okay, so I think the first derivative that we typically do we take the derivative, the function f here, this is operator notation, so f is right here. So when you read this, they're taking the derivative of what? Right, this is d dx. This is the derivative of the sine function. Do you guys happen to know what the derivative of sine is? Some of you guys may. Yeah. Some of you guys may already know. It's not uncommon that the derivative of sine is cosine. Okay? And then the real question is why? Okay? So we like to express why. You know, so we're going to say, let's take a look at the function, the sine function. And of course, all that time we used to find that derivative using the definition of sine, ladies and gentlemen, we're going to apply the definition. So this is f of x plus h minus f of x everything over h. All right. So that's your definition. So, you know, we had a lot of work with definitions. Wasn't that the reason why we did all the, yeah, I mean, that was the reason. So, okay. So we have sine of x plus h minus sine of x over what? H. Okay? So I want you guys to focus over here on what? Sine of a sum. Okay, you guys okay with that? Now, I was sharing this morning with the trig class. You know, what I do share with, when I teach trig, there's like this cheat sheet, and so we share with the trig students where some of this comes from. You know, we're not some of it, we're most of it. In fact, all of it comes from. So we want to know where is sine, what's sine of a sum? Okay? So right in here, what I'm getting at is sine of a sum in gray, x plus h. All right, so we're gonna use that information. So you guys know, okay, what's sine of a sum? It's gonna be sine what? Sine x cosine h, okay? Sine of a sum plus cosine x, what?
Sine y.
Sine h.
Yes, sine h.
Yeah, because you got the sum x plus h there. That's going to replace, ladies and gentlemen, right up here, sine of that sum. So as you can see, what's going to start to happen now is you get some, what? Running out of space. So I'm going to put down sine x cosine h plus cosine x sine h minus sine x over what?
H.
H. Limit. H goes to 0. So what I'm going to do now is this. I want you guys to notice this here. Sine x gets factored. We factor out sine x, I believe. Okay, so you're going to say, all right, what do we have then if we factor out? I think we factor out the sine x. Let me double check. Yeah. So we got sine x now, and you're going to have now what? Cosine h minus 1, and I'm going to leave this over that h. Okay? And then you get plus cosine x. I guess I have to bring it down because I'm running out of space. Plus cosine x, and then sine h over h. Okay, so I'm just writing this as a sum here. And then I'm leaving this division by your h here. I'm not leaving it with all the terms there. I'm going to put it under certain terms. And I'm going to remind you guys, remember this here. This is as h goes to 0. And you can now think of this function sine and this function cosine, so you guys know. They don't have to deal with h. The variable is x. So you can think of those as constants, okay? So they're thought of as constants. All right. So you have the limit. H goes to 0. In fact, let me use properties there. I'm going to pull out those limit of a sum of limits. Okay, pull out the constant. All I'm saying is I'm going to use my properties of limits right in here. Okay? All right, you guys okay with that? Okay. Now, believe it or not, ladies and gentlemen, you might say, what does this limit go to? What does that limit go to? Well, this limit goes to 0, and this limit goes to 1. Now, if we have some time later, I'll prove it to you. I probably have it in a video somewhere. I might even send that. We'll double check, but you can prove this to people. You know what you could do? Just use the numerical proof. I don't know. Okay, how about this? How about this? Let's do our calculator. Okay? Let's do it really quick, just so you guys know. Let's pretend this is like test 1, and they said to you, hey, can you prove these two things equal that limit of cosine h minus 1 over h goes to 0? It's a two-sided limit. I'm going to use a very small h, close to 0. So let me see if I can do this here. Maybe, cosine h, I'm going to do, and I got to change this to radians. So let me go to radian measure. We're on degree. Whenever in calculus, you don't use degrees for your trig functions, just so you guys know. It's radian measure, real number. So h is a real number. That's not in degrees, okay? Real number. All right, so let's kind of do the numerical approach. Give me a number to the left of 0. It's negative.
-1.
No, negative close to 0. Point.
0, 0, 0.
Right? We're going to use that kind of number. You guys see what I'm saying? And then a 1. Something like that. Isn't that close? So we want cosine of that negative point. All those and then a 1, okay? Minus 1. And I might have made another mistake. I should have thought. Could I put the parentheses here, please? Let me. Oh, jeez. Oh, is that it? Oh, okay. I never really use calculators, ironically. I'm just going to put 0, 0. How many zeros? 3, 4, 5 zeros and a 1, okay? And then I'll say minus 1 and close that, divided by that negative point. 1, 2, 3, 4, 5 zeros and a 1. And as you guys can see from the left, it's 0. From the right, we just use positive now. So parentheses, cosine point 1, 2, 3, 4, 5, and then a 1. Isn't that close to 0 from the right? Minus 1, close that, divided by point 1, 2, 3, 4, 5, and then a 1. And what do you guys see? Also 0. So the left-handed limit is equal to the right-handed limit. That's why I say that portion is what? 0. Similarly, sine h over h around 0. Let's see what's going on. So, again, sine h over h. Okay. Sine negative point 1, 2, 3, 4, 5 zeros and a 1. Close that, divided by a negative point 1, 2, 3, 4, 5 zeros and a 1. Oh, that's 1 from the left. And then you say, okay, what about from the right? Well, now it's positive. Sine of point 1, 2, 3, 4, 5, and a 1 divided by point 1, 2, 3, 4, 5, and a 1. Here we go. Left side goes in 1, right side goes in 1. What does that mean about the limit? It's 1. There we go. So guess what, ladies and gentlemen? That just means this equals what? Cosine. That's the definition of our what? Derivative. Okay, so there's your f prime x. Derivative sine is what? Sure enough, it's cosine. Okay, now we're going to prove the derivative of what? Cosine. Yeah, so if I said to you guys, if you have to differentiate sine, you're going to find that's negative what? Cosine. So now your function here is what? Sine, okay? So let's find what that, the f prime, limit h goes to 0, sine x plus h minus sine of x.
Sir, I think you made a mistake. It should be cosine, not sine.
Sorry, derivative of cosine is minus sine. Yes, thank you. Derivative of cosine. Thank you so much. Okay. I'm just thinking of some things. Cosine x plus h. Now you might say, what do you do? Cosine x plus h. What is that? Cosine x plus h is cosine x. Cosine what? H. Now this is x plus h. Cosine x plus h. And that's going to be minus sine x sine what? H. Okay, so I'm using again the cosine of a sum. So cosine x, cosine h minus sine x, sine h minus cosine of what? X, everything over our what? H. You know what you guys do now? You factor. You say, well, what can you factor? I'm going to factor, the cosine out for those two terms. Okay? So I'm going to do something very similar now. I'm going to do the algebra very similarly. Limit h goes to 0, cosine x, and then we have what? Cosine h minus 1, everything over what? H. And then that's going to leave us minus sine x, sine h. Sorry. Okay. So I'm going to use properties of limits again. So I'm going to bring out my cosine as a constant term because the limit is in terms of h. I get cosine h minus 1 over h. And, I'm using properties of limits. Limit of a difference, difference of limits. That was sine h over h. I know you can't see it over there, but okay. So now again, we have that limit, and that goes to 0. And we have this limit again, and that goes to 1. And so what does that give you? That means this is minus sine what? X. All right, you guys okay with that? There's your derivative. It's minus what? Sine x. So I just proved to you guys that the derivative of cosine is what? Minus sine. The derivative of sine, however, is what? Cosine. These are your proofs. So now this is written in stone, okay? So it's proven to you guys. Derivative of cosine is going to be what? Minus sine. The derivative of what? Do you guys know? Can you get the derivative of tangent? What's the derivative of tangent? You say secant squared. How could that even be? All right, you guys okay with that one? Derivative of tangent is going to be what? Secant squared. You're like, wow, how do we know that? Well, let's prove it. The proof, ladies and gentlemen, derivative of tangent, you know what you do with tangent? You write it as a quotient. I've just proved this to the trig class this morning. That tangent is sine over what? Cosine. Okay? So this is cosine what? Squared. You bring up your cosine and you differentiate what? Sine. In other words, what rule am I using here?
Quotient rule?
Yes. Aren't we using quotient rule? Didn't we learn quotient rule yesterday?
Yeah.
All right. Didn't you guys use some quotient rule? When do you guys want to get started on your homework? Yesterday. Don't be that student that what? Waits the night before your test. You don't, that's not a pretty picture. Okay? And then now what you're going to do what? Right, so you can do the opposite now. You're going to write minus sine and then differentiate what? Cosine. Okay? Okay, So what's the derivative of sine, ladies and gentlemen? The derivative of sine is what?
Cosine.
Cosine. And what's the derivative of cosine?
Negative sine.
Negative sine. Okay? So this becomes cosine squared. Minus and minus makes that what? Plus. And then this is going to be over what? Cosine squared. Isn't that 1? One over what? Cosine squared. Okay? Now, I also demonstrated this to the trig class this morning. Okay? What are you really looking at? We can write 1 as 1 squared. Isn't 1 squared 1? So you're looking at 1 over cosine x. Does anybody remember, what is 1 over cosine of x? Do you guys remember that? I proved that to the trig class this morning as well. That is what?
So that's secant squared.
That's secant. But don't forget you are doing what with this? Squaring it. You put the square right there.
Yep.
So this is the very, very famous what? Proof of the derivative of tangent is what? Secant squared. So how many trig functions are there?
6.
There's 6. How many did we do so far? 3. Okay, where were the others? Let me do this. I'm going to say to you guys, the derivative of cotangent, I'll let you guys know, is minus what? Cosecant squared. Okay, you might say, how do you prove that one? What is cotangent? Write it as cosine over what? Sine. And then use, what do you use? Quotient rule. So you can prove it that way. Okay. So I have you guys try that one out, but I want to differentiate for you guys secant. Do you guys know what the derivative of secant is? Well, let's pretend
Secant times tan.
it is secant tangent. Okay. So if your function is secant, oh, sorry. Do you guys know what you replace that secant with? 1 over what?
1 over cosine.
Cosine. And then, what do you guys use? You use what? Quotient rule. Okay, you're going to use quotient rule here. All right. So, square cosine. Bring up what? Cosine. And then differentiate your what? Sine. And then now do the reverse. Don't forget the minus sign. And then take the derivative now of cosine. So, all right. So what's the derivative here of 1? And what's the derivative of cosine? Is that minus sign? Okay. Minus what? Minus. What's minus and minus? Isn't it what? Plus? So you say, is this sine over what? Cosine squared. All right. So you might say, Mr. Judge, how did you get the derivative of secant being secant tangent? How did we get that? Well, when you take a trig course, there's something called what? Proof. Okay? And I know from my experience teaching trig, not everybody likes proof, right? And you kind of have to tell them, hey, guess what? Proof is good. It simplifies things in your life. That's why we do it. And so, hopefully students believe you, right? So let me share with you guys what I mean. Isn't cosine squared cosine times cosine? Okay, you guys okay with that? And I can write sine now just using a little bit of algebra, arithmetic. This is 1 over cosine. Okay? Right? You guys know what I'm saying? Now, you may notice, hey, what do you have here? Sine over what? Cosine. And then what is this? 1 over cosine. So what's sine over cosine? Tangent. What's 1 over cosine? Secant. Is that true? And then the order in which you multiply does not matter. I can write it as secant tangent. So, ladies and gentlemen, this is the proof of what? The derivative of secant being secant tangent. All right. You guys okay with that? Isn't that kind of amazing? You guys use tools that you learn. Quotient rule. And then some of those derivatives of a constant being 0, derivative of cosine being minus sine, and then just doing a little bit of that proof. Now you got secant tangent there. Okay. So that just leaves us with the last remaining what? What's the derivative of cosecant? It's minus cosecant what? Tangent. Cosecant is 1 over what? Isn't that 1 over sine? Write it as 1 over sine, and then you use, right in here, you're going to use what? Quotient what? Rule. All right, you guys okay with that? So this is the derivative of sine, cosine, tangent, secant, cosecant, cosecant. And I recommend that you guys know those derivatives like you know your name. And you go, really? Why? Because to get started on some of this, take a look, not back here. Take a look at the resources I pointed out for you guys. 261, right in here. Derivative of trigonometric functions, right? So if I said to you, they're going to give you a function like this, maybe they say, I don't know, I'm going to try this x squared sine x. I'm not going to give you these exact ones because I don't want to take all the fun from you, because these are the ones you guys are going to do yourself. Oh, Mr. Judge, really? Yes. And then If you get stuck, what do you guys have? Your tutor right here. You see what I'm saying? All right, so let's do our own versions, okay? Like something like this. You say, how do they expect me to differentiate this? Well, what do you guys think you would use? Anybody start working with that homework?
Which one?
Any of them? Product what? Rule. So I'm going to actually use my operator notation, okay? I think this is really helpful. Okay, so you say, what do you mean? Well, what's the derivative of a product? You pull out the first function and you differentiate the second function, okay? And then you add, but you do the reverse. Pull out the second function, differentiate the what? The first. Now, what do you have to know? Do you guys know what the derivative of sine is? Thank you. What's the derivative of x squared?
2x.
2x. Good. What did you guys use here?
Power rule.
Power rule. You guys okay with that? Okay. So that derivative is going to be x squared times cosine x, right, plus 2x times what? Sine x. You are done, ladies and gentlemen. Easy peasy, lemon what? Squeezy. Yes, question.
I have a question. Do you
Yeah.
have to factor out like x?
Nope. Nope, you're done.
Okay, that's it.
Mm-mm. That's it. All right. Let's try another one, right? Example. What if they give you cosine x over 4x and they want you to differentiate? Okay, I'm working with two computers, so I've got to go back and find what I need. So you say, what do I do here? Well, what are you guys looking at? Looking at a quotient, is that right? So in honor of the work that we've been doing, quotient rule. Take the denominator and what? Square it. And that's 4x to the second power. And then bring up the denominator and differentiate your what? Numerator. And now subtract and do the reverse. What's the derivative of cosine? What's the derivative of 4x? Is that 4? Okay, so let's put it together now. You're going to have what? Negative 4x sine x minus, we like to put the constants first, okay? So put those there. And 4x squared becomes what? 16x squared. And I'm just going to say now, you guys are what? You guys are done. Is that easy peasy lemon squeezy? Yes. I would say, what do you say that again? You can do this. Let me do this here for you guys, okay? What you can do is a couple of things. You say, can I factor out a -4?
Yeah.
Right? So you say, you got -4, and then you have x sine x plus what? Cosine x. Now that's going to be over 16x squared. And then, does 4's go away? Yeah. So you get negative x sine x plus what? Cosine x. Now everything over what? 4x. So here's a nice factored version for you. Okay, you guys okay with that one?
Professor,
Yes.
in the test, to what extent do we have to like simplify our expression?
Well, I think really what's going to eventually happen is that you have a very good question. Eventually what's going to happen is you're going to use derivatives. Now, as you use them, you're going to do a lot more of the algebra of simplification here. So I would say down to this point is what you want to do. Or you can simplify here. Some of my students, you know what they do? They stop right here. If even that. Some people just write down the operator notation.
You can get a point for that.
If it's out of 10 points, we'll just give you one maybe. You say, why? Because the point is that you eventually learn how to use a derivative. See, these are tools. These aren't just, we're not just doing like jumping jacks and then push-ups for the sake of doing jumping jacks and push-ups. Those are all exercises in a bigger picture. So what you're seeing here is exercises in a bigger picture. You're just seeing part of it. Some people need to do what? They got to review some algebra, you know. But so yeah, so the point that starts to happen is where do I go and finish my simplification? It's kind of it's a tricky kind of question. Would I have given people credit on a test for doing this by asking a derivative? Yeah, I think I would give people that credit like I showed you guys earlier. And yes, should you maybe go further? Yes, but you'll see in our future, you know, how far we go so that you can start to use the derivative.
So if you get the answer for the gray one, you get like 4 points, right?
If it's, hey, find those derivatives, I wouldn't mark it wrong. I'd say, great, you got that. If you did the blue, I'd say even better.
But both of them are acceptable. Okay.
Okay. Because when you first start to do this, what's the point? Okay, remember, you guys are starting your experience with derivatives. It's not ending here. It's just what? Beginning. All right, you guys okay with that? So the whole idea, I think, at this point is to show people how you get what started. And it's really about using properties as well. So if they say 2 tangent plus 5 what? Secant. Okay, you guys okay with that? So you're going to differentiate what? 2 tangent plus 5 what? Secant. So you have the derivative of a what? sum is now sum of what? Derivatives. Is that true? You guys see what I'm saying? So here's every gory detail with operator notation. You can differentiate 2 tangent x plus 5 what? Secant x. And then now what do you guys want to do? Pull out your what? Constants. So if you pull out my constant, what do you get? 2 derivative of what? Tangent plus 5 derivative of what? Secant. Okay, you guys okay with that? And remember, where are your constants now? Here and where? Here. So take a look, right? So far, all we did was what? Operator notation. You didn't even take a derivative. You just did notation. Okay, so what's the derivative of tangent? Do you guys know that? We just learned that today. That's secant squared. This is why I say you want to know these like you know your name. Secant squared. What's the derivative of secant? Yeah. Okay. So that your derivative now becomes 2 what? Secant squared plus 5 secant tangent. There you go, ladies and gentlemen. Easy peasy lemon what? Squeezy.
I factored out secant.
Don't have to.
Okay.
You're what? Done. Okay, you guys okay with that? What do you guys think? Is that okay? Not too bad? I just say, remember, you want to get started on these as soon as possible. All right, how about this one? Get rid of tangent over square root of x. Okay, so use operator notation. Do the d dx of, what is this? Tangent over the square root of x. Okay, what does quotient rule say? You take that denominator and square it, bring up your denominator, and you differentiate the what? The numerator. Minus, do it backwards now. Take that tangent and then differentiate the what? Square root function. What's the derivative of tangent? Good. What's the derivative of the square root of x? Did you guys have that memorized yet? Didn't I tell you it shows up all the time? Now doesn't it, right? All right. Okay. So let's put this together. Square root of x secant squared minus tangent x over 2 square root of x divided by what? What's the square root of x to the second power? Isn't that just x? Okay. 2 squared of x. Okay, so you say, what kind of simplification do I do here? Well, you're going to subtract rationals. What was that little trick I showed you guys with? Put that numerator and denominator by what? 2 squared of x. You guys okay with that? It's really the number 1. So, I'm actually showing you guys as we go along how to do some of the simplification that we'll be using in the future. That's kind of a good thing. And then now you got to know some of these algebra here, right? What's this algebra here? What's the square root of x times square root of x? Is that x? So this is going to be what? 2x secant square root of x minus tangent x over 2 squared of x divided by x. Two x secant squared x minus tangent x. You guys know what you're looking at? What are you guys looking at? Right? In terms of the algebra, do you guys know what you're seeing here? What is this? This is a over b divided by c. This is a complex fraction. So yeah, let's kind of write that down here. Okay. Over b divided by c, which is a over b times 1 over c, which is a over what? bc. So I'm going to just write it now here, divided by the x. And then you say this. You say 2x, secant squared x minus tangent x over 2 square root of x times 1 over x. And this now would be 2x what? Square root of x. And you are what?
Finished?
Done. Mm-hmm.
Professor, just another question. Do we have to write like tangent as sine over like cosine?
No.
Like
Tangent x
do,
is fine.
Like further simplification?
You're not asked to convert these to sines or cosines.
Okay.
Tangent is a perfectly legitimate function, just like secant.
Okay. Got it.
So you don't have to convert secant to cosines
I
or.
thought we have to like convert all like these kind of functions into like sine and cosine.
Nope.
Okay.
So there you go. I mean, this is as far as the algebra that, that's as far as you take it. Just looking at some of these functions. Okay, just looking at some of these examples that I put down there for you guys. How about this? Let's just say minus cosecant. Okay, just to kind of change that up on you. Let's see if you guys remember some of these properties here. Okay. right? Isn't this operator notation? And you're taking the derivative of a what? Difference. What's the derivative of a difference? It's difference of derivatives. Okay. X to the what? 2/3 power. All right, so what would you guys do now with this? You got to take the derivative of x to the what? 2/3 power. Does anybody know what you use to do that? What do you guys use? You're going to use what again? Power rule. Is that right? So that's going to be what? 2/3 x to the what? 2/3 minus 1. Okay, what's the derivative of, excuse me, cosecant? Minus cosecant co what? Tangent. You guys have to know that derivative like you know your name. So that list that I gave you guys this morning here that we worked on, that we proved, you guys want to know that. All right, and then what happens? What's minus the what? Minus. Yeah, it's going to be plus. So I just want to remind people now. Don't forget about your arithmetic over here, though. You get 2/3 minus what? That minus 3/3? 2/3 x to the negative what? 1/3? Is that true? Right? 2/3 minus 3/3. Okay. What's minus the minus? Plus cosecant co what? Tangent. Now, like I sent you guys last weekend, what does that mean? Do you guys remember? What does that mean? Isn't that 1 over what? X to the positive 1/3? Okay, and then what is 1 over x to the positive 1/3 going to give you? That's really 1 over the cube root of what? X. So you have now 2/3 times 1 over the cube root of x plus cosecant cotangent. So what do you guys do with the algebra here? 2, 3 cube root of x. What did I do here? It's really not algebra. It's what? You're multiplying two fractions, right? Horizontal across. Okay, so you're going to multiply those two fractions. And you are what? Done.
Do we have to write the common denominator?
Well, the common denominator would be 3 cube root of x. So you're done with what you need to do here in terms of the algebra. There's no other algebra to do. This is fine as a simplified answer.
Cool. Got it.
Okay, so remember, this is how you start taking your what? Derivatives. This is your start. So I'm just looking at some of the stuff I did. Oh, okay. We have to give you x secant x minus 4x plus 7. Okay, so this is an exercise in using your properties and derivatives. Use this notation, right? What's this notation? Operator, yeah. So what are you doing now with this? Yeah, well, we got let's go from the beginning here, right? You got difference and a sum. Okay. So right in here we have to use what? Product what? Rule. I can differentiate 4x. What's that derivative? 4. Good. What's a derivative of any constant? Good. So it looks like the real work is going to be right where? Right here. Is that right? You say, what work are you talking about? Well, it is the first function times the second function. We're using product rule. So pull out the first function. Differentiate the what? Second function. Plus, pull out the second function and differentiate the what? First. Isn't that your product rule, ladies and gentlemen? All right, you guys see what I'm saying there? Okay, now, what's the derivative of secant? Secant tangent. You guys have that list there, maybe?
Yeah.
What's the derivative of x? 1. Okay. So you want to take a step back and try to say, okay, what do I write down, right? You have x secant what? Tangent. Plus secant minus what? 4. There you guys go. All right, you guys okay with that? What do you guys think? Is that okay? I don't know. I think they're doable, but you have to keep up with your what? I think you got to keep up with homework. Should we kick it up?
Yeah.
Ooh, well, okay, let's try this, something like this. How about if they give you 2 plus x sine x? All right. So use your operator notation to get the derivative. So this will be 2 plus x times sine x. Now, what rule do you guys think you'll use? I'm going to highlight this for some reason. I'll highlight this for some reason. So what do you use? What's this going to be? You're going to use what?
Product.
The product rule. All right. So how would you use the product rule? Do you guys remember? You pull out the what? First function, and you differentiate the what? Second. Pull out the second function and you differentiate the what? The first function. What's the derivative of sine? Cosine. What's the derivative of 2 plus x? Is that 1? What if you said, I don't know? Okay, use your properties here then. Derivative of 2 plus the derivative of what? X. Derivative of 2 is 0, and the derivative of x is 1. Is that true? Okay, you guys with me on that one? So this is going to be 2 plus x cosine x plus what? Sine x. And you are what? Done.
No need to distribute like
Nope.
cosine, right?
Nope.
Okay.
Okay, so double check. So right in here, maybe you said, I don't know what that is. Well, you know, again, you want to do that first homework assignment so you can know the derivative of 2 plus x is going to be just x. I'm sorry, just 1. Because as you can see, when you have product rule, quotient rule, that's the least of your worries. That's why you guys want to do that homework in order, and, you know, that's why I put the solutions too, so that people can go back and take a look at that if they make an error, you know. Should we try what time to get out of here?
We have 5 minutes.
5 minutes. Okay. Well, whatever. I think what I'll do is this. It's the odds. So let's go back and let's remind you guys here. Okay. Derivative of trigonometric functions are here, and then the odds, I believe, are over here. If you look at the video there, you go, oh my God, the video. Let's see. Yeah, it looks like the video is fine. Ooh, an hour and 22 minutes of what? That's in case you get what? Stuck. No, this is a calculus class. So I have a bunch of calculus like stuff, you know. Yeah, it's on there. It's on that website. And so on your assignment, you say, well, what happens here? This is the derivative of trigonometric functions. It's actually, it may not even be another class at all. It's this stuff I've done on my own separate. Like when you make some of those worksheets, you know, people like to use some of those. Like they want to see some solutions, you know, and that's kind of normal. I think it does. I think it does personally. What's it called? Derivative trigonometric function. So maybe I should put the title. So yeah, I mean, you guys have more resources here in this class than any others. They are free. I don't engage in working with the publishers.
Yeah, especially not even
Well, I don't work with the publishers that are going to charge you a license fee for stuff that doesn't work very well, kind of. I remember, you know, my daughter used to complain all the time. Dad, I hate that stuff. I used to, you know, look at, you know, these publishers are always trying to get, you know, access to students to charge them for expensive textbooks and resources. And they do come in my office and they even say to me things like, oh, are you aware of our resources? And I'm aware. What do you use? I go, I use my own stuff. Really? Do the students like it? I go, well, I don't know. And they say, have they ever asked to use our resources? I say, never. I'm like, oh, well, you may want to look at them. I'll say, okay. Don't know what to tell you. Huh? I can be bought. They can buy them. Maybe I should tell them that. Shannon, you should be my business manager. I like that. I don't think that way. I should say, hey, why don't you guys buy my resource? I don't think that. I never said that. I know the district wanted me to use resources to create a course in statistics, which I did. A couple of years ago. And then I remember somebody made a comment and they said, oh, you're just going to pay Daniel $1 million and that's it? And I'm like, yeah, that sounds right. I didn't do it for them because I wouldn't do that. And they wouldn't pay me $1 million. They had me do it for free.
Oh, no.
Do you guys know what I mean?
You need at least royalties for every year that they use it.
What's your major again?
Environmental science.
This is how people have gotten rich. And I'm not saying I'm doing this to get rich. No, I'm not. How many likes do we even get in the videos? 2.
No, you can check the total of likes you've gotten and like the total of views.
Only 2.
No.
People don't look at.
You have like 3,000 subscribers.
Yeah, you know what? And I don't even know how that really works if you guys want to know the truth. Like if I want to give information, does it go out to all the subscribers?
Well, you can if they put notifications on.
Oh, they got to have notifications. I see. See,
Yeah.
don't even know.
That's why you need an intro. You like push the little bell icon.
Is it? See, Shannon, you got to be my manager because push my what?
The little bell icon. 'Cause
Push the little bell icon.
yeah,
You
the
can be
bells are
next organic
notifications.
chemistry teacher.
In the video, while you're talking, you could tell them, like, click here.
Click on the little bell, everybody,
Yes.
and then you get notifications, and I can send it to all of you. That's a pretty good. Yeah, I don't know. I gotta figure some things out. Anyway, okay. Thank you guys for giving me that information. Take care. Have a wonderful weekend.